This video will review how to construct a copy of an angle. To construct a copy of an angle, we're going to take and we're going to tie it back to the rhombus. Now, we need to find what property of the rhombus would help me to understand how to do this construction. Now, if you think back to a previous video, there were multiple properties besides the definition of a rhombus. Those properties are opposite sides are parallel, opposite angles are congruent, diagonals bisect each other, diagonals are perpendicular to each other, and the diagonals bisect the angles of the rhombus. If I want to make a copy of an angle, I need this property right here. Opposite angles of a rhombus are congruent. So if I think about what a rhombus is, so if it's a rhombus, then opposite angles are congruent. So if I can turn this picture into a rhombus, the angle A and the one that's away from it will be congruent. To do the construction, I need to go back to the definition now. A rhombus has 4 equal sides. Right now I have 2 rays, which means I have no equal sides. Right? I don't have any of these with a fixed length. So I get to choose what I want to make the lengths of my rhombus, meaning that they weren't given to me. So if I just take my compass, set it to any arbitrary length, pick something convenient to work with, you don't want it too small and you don't want it too big. So if I draw a circle centered at A, and find where it intersects the 2 rays, we'll call those B and C. This defines the length of my rhombus. My rhombus is going to have lengths of AB, which is congruent to AC. Now I know these lengths are equal because they're both radii of the same circle. So this gives me 3 vertices. A rhombus has a 4th vertex, so in order to find that vertex, I'm going to take the same length as AC or AB, and I'm going to draw one circle centered at C, or a part of a circle, in this case an arc is enough, and then one centered at B. And I'm going to find where they intersect. So again, one centered at C, same length as before, so this circle, and then one centered at B, same length as before. Where they intersect, let's call that point D, and I see my rhombus. My rhombus is rhombus ABDC. Now in particular, we're trying to find a copy of an angle. So if we can turn this into a rhombus, the angle that is on this side, angle A, would be congruent to the angle that is opposite from it, which would be angle D. So what I've done is constructed a copy of a given angle. Those angles A and D are congruent. Now let's have you try it. Sketch a picture like this one, and I want you to make a copy of angle A. Use the steps we just used. Use the idea that if it's a rhombus, opposite angles are equal. Try it at home, pause the video when you're ready, resume it, and then check your answer. I'll give you a minute to get ready. All right, hopefully I've had a chance to do this construction. Again, because they haven't given me any of the side lengths, I get to choose an arbitrary length. So if I set my compass to this, and find where it intersects both rays. I don't need the full circle as long as I've got where it's intersecting both rays. So we'll call this point B, and over here C. I need to find the 4th vertex by taking the same radius and centering one circle at B and one at C. I need to find where these last 2 circles intersect, and that would be right there. This length, which we'll call AD in a moment, or CD in a moment, is the same length as AC, is the same length as AB, is the same length as BD. So this is vertex D. So drawing in the rhombus, I know that I've made a copy of angle A because, again, if it's a rhombus, opposite angles are congruent. So angle D is congruent to the given angle that was called angle A. So we've constructed the congruent angle. All right, I hope this video helps you to understand how to do a copy of an angle, and thank you for watching.